Discrete time Fourier series. The discrete time Fourier series for a discrete time signal x of n, that is given by equation sigma k varies from 0 to n0 minus 1 dk. Here k is the suffix to d. Okay, e raised to j k omega 0 n. X of n is equal to sigma k equal to 0 to n minus 1 dk e raised to jk omega 0 n, where dk is the Fourier series coefficient. Dk is known as the Fourier series coefficient, and n0 is the fundamental period. Okay, dk is known as Fourier coefficients. Okay, and n0 is known as the fundamental period. Okay, and one more thing is unknown here, that is omega 0. Omega 0 is equal to 2 pi by n0. This is the Fourier series representation of a signal x of n. Any discrete time signal x of n can be written or can be expressed using this equation. Can be expressed as the Fourier coefficients using this equation, and dk is equal to 1 by n0 sigma n equal to 0 to n0 minus 1 x of n e raised to minus jk omega 0 n. Okay, this is the equation for the Fourier coefficient dk. And the next topic is the Fourier spectra of x of n. The coefficient of for discrete time Fourier series dk, that can be expressed in terms of magnitude and phase. Okay, that can be, dk can be expressed in terms of magnitude and phase as dk is equal to modulus of dk, that is the magnitude, and then it is followed by e raised to j dk, that is the phase plot. Then we are going to come across with the two new terms. One is the magnitude spectrum or magnitude plot, and the other one is the phase spectrum or phase plot. Magnitude plot and the phase plot. Magnitude and the other one is the phase spectrum, PHS phase. Okay, first of all, let's discuss about the magnitude spectra. Magnitude spectra is it's nothing but the magnitude versus omega frequency. Magnitude versus frequency curve. That is magnitude spectra is the, from the word itself, from the word magnitude spectra itself, we can define we can find the definition for magnitude spectra. From the word itself, we can say that it is a graph in which magnitude versus frequency omega. Okay, magnitude along the y-axis and omega along the x-axis omega, and this is a modulus of decay, that is magnitude. That is mod decay versus omega graph, that is known as magnitude spectra. And next is about the phase spectra. From the sentence also I can find the definition. Phase spectra is nothing but the phase versus omega, phase versus frequency. That is a graph connecting phase with the frequency, in which the phase is plotted along the y-axis, and of course the frequency along the x-axis. This is phase decay, angle of decay versus